One part of classification taxonomy is identifying species, categorizing them, putting them into groups with similar species. And one of the tools used by scientists is called a dichotomous key. Okay? And that's what we're going to learn about today. A dichotomous key, what it is, how we use it. A dichotomous key is basically a tool, a set of steps you follow that allow you to identify an unknown species. Okay? I have some examples here. These are some dichotomous keys I had to use in college. So this is a key to fruit and twigs. So basically, if you took a twig from a tree, you can follow along a set of steps in this key, and it would eventually tell you what type of tree it was from. For example, the first part of this, and the way these keys work is they have a set of descriptions. They're usually two. Each number has two descriptions. You look at it. You look at your unknown species. You decide which one applies, and then you follow the instructions. It may tell you to go to another set of statements, or it may tell you the identification. Depends if you've gotten it. For example, this dichotomous key to fruits. Let's see where it starts. All right, number one. Is the fruit a cone or cone-like, or is the fruit not a cone? If it's cone-like, we go to 2. If it's not a cone, we have to go ahead to 27.
It's like those adventure books.
Yeah, it's like choose your own adventure book. 27. Is the fruit have a thin wing at the end, or is it not winged? And again, it'll send us to another set of steps. Eventually, after following all of these steps, it'll finally reach, it'll say, okay, it is a rhododendron maximum. Okay, it'll identify the actual species. Here's another one. This is a dichotomous key that would help you identify basically any herbaceous plant in the Northeast United States. This is called the Manual of Vascular Plants of Northeastern United States and Adjacent Canada, 2nd edition. So you can look at this later on, but look at the printing. It's super small. It has a description of every species and a key to identify them. I had to use this in my botany class. This last one, this is from my ichthyology class. This is a dichotomous key to fish in New York State, inland fish. And so that has a long key, gives you all the statements, you know, are the pelvic fins abdominal originating behind the base of the pectoral fin, or are the pelvic fins far forward? And if it's far forward, it's a codfish. If it's not, you have to go to another thing. So again, just another tool to help you if you went fishing, caught a fish in a lake in New York State and didn't know what it was, you can follow through this key, follow your steps, look at the fish, it would eventually you would identify it. So these are dichotomous keys. We won't use keys that are this complex or this long. These are real ones that you might actually, a scientist, a naturalist might really use. The ones we use are kind of simplified a lot, but it's the same process that you would use. You have a question, Dan?
How many species are there?
Oh, millions. There's millions of identified species. So you wouldn't have like a dichotomous key to all living species, right? It would be this giant thing like this. It would be a dichotomous key to fish found in a certain area usually, or plants found in a certain area. So they have to be more specific.
Do you find a worldwide one, or would that just be?
I don't think so. I mean, I'm not sure if this has been done, but if you had them all digitally, you could create like a worldwide universal dichotomous key, I guess, by linking all these smaller dichotomous keys. I don't know if such a thing exists. I mean, really it works. Did you ever play that game? It's a little electronic game, 20 questions.
Yeah.
Where you think of something and then it asks you a bunch of questions, right? And again, it's basically just asking you yes/no questions. But sort of the program inside, what is it really doing? It's doing the same thing, right? It's setting up a key, process of elimination, where it breaks down, you could be thinking of, hundreds of thousands of things. But as it asks you questions, it eliminates a large set. And then it gets more and more specific until hopefully it identifies it. Evelyn?
I have an Alexa, and if you ask her to play the animal game, then you think of an animal, and then she asks you questions,
Oh, that's
and you
cool.
say yes or no, and then she tries to guess.
I'll have to try it out. I have a Fire TV, I have to do that. All right, so let's look at an example here. So obviously you know what these animals are, but let's pretend that you didn't. And you wanted to identify, say, what the heck is this crazy looking thing? Well, follow through a dichotomous key. So I start always, every time you're using the key for a different sample, you start back at the beginning at 1. So you read both statements, 1A, 1B. Are tentacles present or tentacles absent?
Present.
So for this, they're present, obviously. So now we go to 2. Does it have 8 tentacles or more than 8?
8.
This has 8. All right, well, we've identified it already. It's an octopus. How about this? Tentacles present or absent?
Present.
Absent.
No tentacles. Because legs, no tentacles.
Oh,
Absent. We go to 4. Does a pair of giant pink claws?
No.
Pink body?
Yes.
Yes. This is a shrimp.
Wait, what's the thing on the bottom?
That's the shrimp.
Is that anatomy?
That's a crab.
So we go here. All right, tentacles present or absent? Absent. We go to 4. Pair of giant claws?
Yeah.
Yes, that's a crab. Okay, tentacles present or absent?
Present.
Present. We go to 2. 8 or more than 8?
More than 8.
More than 8. Now I have to go to 3. Tentacles hanging down
No.
or tentacles come from the top?
Top.
Come from the top, but you see it. So this is how they work. Let's do another simple example. Oh, don't look at that. Now this key has been updated. Let me see. Yeah, you have a different version. We updated it, but it doesn't really matter. Just follow along on the screen. So we have 4 finch species. Now this is a little bit more realistic because you probably don't know the name of those 4 finch species, but you can easily find it out using a key. So let's look at this finch. Is the beak very thin and the upper beak is much larger than the bottom, or are the top and bottom nearly equal in size? Nearly equal. We go to step 2. Is the beak smaller? Is the beak is small and lower beak slightly smaller than the top, or is the lower beak as large or larger? Larger, larger. Those separate. Is there a bend between both beaks, or is the lower edge of the bill mostly flat? There's just bend at the end. So this is a mangrove fish.
Did you write that?
Yeah, yours says something different.
Is it more complicated, like more specifically?
I mean, the complicating part about a real dichotomous key really is the vocabulary. Like, if you're an expert in fish, like you probably know what most of the terms in here mean. But there are some pretty complex terms, like when I read to you, and you can look at this as we work on our activity later on. Where's the key? And in both of these big ones, this isn't all a key. It's a key, and then it's a description of each species. That's why it's so there. So for example, this is to tell you which family the fish is. Like I'm looking at X. Is the dorsal fin spiny with soft parts continuous or separate? Close together so the space between them is less than the length of the dorsal base. So to understand that, you have to know what the dorsal fin is. You have to know what the dorsal base is. So you have to know some terms. But if you were familiar with fish, and in here, it helps you with that. It shows diagrams of what these things mean. You can figure it out. So there are sometimes some specialized terms you have to know about anatomy. All right, let's look at this finch. Is the beak very thin, upper beak much larger than the bottom beak, or top and bottom about equal in size? Beak equal in size. Is the beak small, lower beak slightly smaller than the top? Or is it as large or larger? Yeah, that's the ground finch. So look at this top right one. Beak very thin, upper beak much larger than the bottom? Or is they equal in size? Equal, go to set 2. Is the beak small? No. Lower beak's larger, go to set 3. Is there a bend between the beaks, or is the lower edge mostly flat?
Mostly
Flat, this is the vegetarian finch, my favorite. And then finally, is this beak very thin? Upper beak is much larger than the bottom?
Yeah.
It is, that is a warbler.
How do you say it?
Warbler.
There's no color.
It looks like a wobbly.
All right, so yeah, now we have a longer key.
What the heck is that?
Um,
Looks like the tail of the one.
that you can use to identify these made-up species. We're actually not going to do this right now. I want to give you some more time for your lab, but it's basically where you follow through. Again, this is just a little longer, but you just have to read, look at your unknown species, see which ones apply, and then eventually it'll be identified. So any questions about a dichotomous key?
Potato.
All right.
It's all your emotions.